Hello, and welcome to this electrical domain session as part of the buildingSMART International Standards Summit, Valencia 2024. Thank you for joining. My name is Laura, and I will be your moderator today. Today we've got two different presentations. The first one, transforming electrical engineering, the convergence of BIM and digital twin technology. The speaker is Frey, and the second one will be ACA solution for electrical planning by Andrea Aiello. This session is scheduled to last 90 minutes, including time for questions at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to the speakers, I would like to remind you that this is an hybrid event. For online attendee, your microphone will remain muted for the duration of this session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For the attendee here in the room, please keep the background noise to a minimum. And if you wish to make a comment or ask a question, please raise your hand and use a microphone. I would also like to bring to your attention that buildingSMART is committed to ensuring that participation in development of standards is unrestricted and the process for their adoption is transparent, and standards that are developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct, and I would like to hand over to Christian.
Thank you very much. Hello, thanks for coming. We need to talk BIM. We can talk Spanish, but how to talk BIM? It's completely different. And why do we need BIM for electrical planning? This is why we are here now, to show you what we can do and what is necessary to do also in future. And the electrical domain, we founded it two and a half years ago. So it's brand new, more or less. We are also trying to define our IFC specifications and all that stuff. You've seen also in this morning, in the TechBox presentation, how the TechBox is used in the electrical domain. So things are moving on, and that's why it is necessary. So at the end of the day, BIM can help to improve the communication and coordination between the different stakeholders in the whole building life cycle. So we have a construction company, we have a plumbing company, we have architects, we have so many people, and they all have to work together. And then this coordination must be also standardized, and that's why BIM defines a process that helps us here. And by creating a central digital model, the building, BIM can also help to identify and resolve potential conflicts even before they occur. So this can lead to a more efficient and also a more effective construction process, which at the end of the day saves time and money and makes everybody happy. So next to this, BIM can help to improve the performance of the building automation and control system. And by providing the details of the digital twin of the building and its systems, BIM can help to optimize the operation of these systems and reduce energy consumption. And BIM and the digital twin have the potential to significantly benefit the development of the building automation standards like BACnet, KNX, and many more. So the electricity is something that has to be planned correctly and is something that is very well needed in the operation phase. And we also learned quite often that without electricity, nothing works in this building. Do you agree? Hello, are you still here? Okay. So why BIM in the electricity? Planning reliability, I mean, it's the same for our electrical system as you do it for the construction phase and so on. So at the end of the day, we have an entire life cycle of a building project, and the electricity must be planned also quite well as the plumbing and everything else. And the so-called digital twin is it's also getting more and more complex, I must say. In the early days, you had the building where the electricity came in. You had your distribution panel, you had a floor panel, and then you had your socket. The cable was big in the beginning, getting thinner until to the socket. You need to know whether it's a one-phase or three-phase or whatever. That's it. Today, it's getting more and more complex, and it must be planned much more precisely, because now you have photovoltaic on your roof. You have your e-charging in the garage. So the thick cable also runs from the top to the down, to the floor, to the garage, where your electric vehicles will be placed and connected to the network. And in future will also be the buffer for the electrical power within a building. So this means the planning is getting more and more complex. We have to look at the new things. It has to be identified, because when you do incorrect planning of your electrical network, then you have losses on your cable, which cost you a lot of money in the operation phase. In the construction phase, you don't care, it still works. But in the operation, it costs you a lot of money. And the operation phase is a much longer time than the design and construction. So BIM will change the way we work. And for us in the electrical domain, it is also important that we do not only show these nice pictures. We also have to give our electrical planners the symbolic that they are used to in certain oh, sorry. Thank you. Laura said I will forget it, and I did. Okay, so here you see there the a schematic diagram that we need, and this will also change the method on how we will work in our electrical domain. Next to this, we will have also our sustainability requests coming from the governments, that you have to reduce your CO2 footprint, you have to be more efficient and so on, and then we need to know how can we do this, how can we apply it already in the design phase, what can we prove in the design. We may have to prove also in the design phase that we already do a sustainable electrical network within this building, and also the efficiency of the electrical network we have to prove to our customers or also to the real estate owner, and also the ability to simulate power consumption behavior. How is the power flowing within the building, up and down and vice versa? I don't know. So this is something that must be available already in the planning phase, and we need to connect to virtual and physical. We need to connect the virtual and the physical world later on in order to see where are our problems while we run this building. So the challenges we are facing in our electrotechnical trade in the building are in the design phase: inefficiency, using different tools and stuff like that, no standards, everybody, nothing is compatible and so on. This is something where teams, they have to work together, and it's not only the electricians, but it's, as I said, without electricity, nothing works. So when you go to the men's toilet, the flushing of the toilet needs electricity. And this must be coordinated with plumbing and. So many of these things are important already in the design phase. Then new energy efficiency regulations. So the government gives us new regulations that we have to fulfill in the design, but also for existing buildings, that we know exactly what to do to be compliant with all these regulations. And then there is also a transition of new energy landscape transition usage, such electrical vehicles, what I described before. You have your microgrids within a building where the power runs up and down. You need renewable sources in your building. Maybe you will have a windmill on top or whatever, photovoltaic for sure. And also the as I said, the electrical digital twin. We have this real world and the virtual world, and we have to do simulations also to find out where can we improve. And in the build phase, we have this inefficiency, 90% project costs and time overruns in 30% rework and waste. Waste is also a big issue, I must say, when you don't find your products on site. Then you have to reorder them, and suddenly you have too much of them. You throw them away, or you order too much, more than you need, and all this is something that also creates or is a sustainability issue. The compliance market transformation from sustainable and compliant buildings, and also transition to the digital process. You want to use your smartphone in the building to find your way. You want to use your smartphone to switch on the light and all this stuff. All these things must be taken care of. And in the operation and maintenance, we have maintenance issue where you have to do regular inspections, let's say for your fire detection system, or also for many other things like your elevators, escalators, and so on. So all this must be clear that you have this already that this is fulfilled. It's done very inefficient. We need BIM because we have no time to. I mean, a lot of people also think that when they have a PDF, that they are digital, but this is just a digital paper. It's not what we need to do. You saw it before. We need to have these drawings. We need to have these models, different colors in the models to exactly identify the product that causes problems and all this stuff. So this is why we trust on BIM and also on the software in the design and in the operation. Yeah, then meeting the sustainability goals and not only saying, well, I'm sustainable. No, you have to prove it. For this, you need the data and smart meters and stuff like this. They deliver data, but you need to know whether you are in a level where it is okay or where you need to improve. And also the understanding power cost management and multiple point solutions, all this stuff makes it a challenge. Then the future in the electronic trade, we have so many phases where we start with the building design. We have our dimensioning and simulation of our electrical network. We have our CAD for the electrical schematic. We have our panels that must be planned correctly. We have at the end we want to know how much will it cost. So we need to have a quoting. For this we need to know already some more details, and then we go into the planning, commissioning, and the operation. And all this together is our electrical digital twin at the end of the day that we would like to see in a modern building not only for the skeleton, but also for the electrical network. So here again you see renewable power. It's getting more and more interesting. Then you have your power distribution, your electrical power distribution from the medium voltage to the low voltage, and then to the low voltage final distribution board, and at the end of the day to the socket. This is in what we are working on in our electrical domain, in specifying all these things in IFC. Again, here you see the different systems that we are connected in to the lighting system, to the security system, and building automation system, HVAC, and all this stuff. So everything needs power, electrical power, and needs to be planned and distributed correctly. Here's the same in another drawing. And at the end of the day, you need also to know what is inside my building. And a colleague of mine, he said, well, a building is nothing else than a warehouse, like an Amazon, where you have your shelves and stuff like that. So we need to know what's in there. We need to know how it is connected. We need to understand where are, let's say, where is abnormal operation at the end of the day, and what can we also take on learning when we go into our next design. Here, this is the paperwork. Still, a lot of people run around with this digital paper. They think they have an iPad in their hand and they are digital. No, we need to have this cube tower where you get the information that you need, and not too much and not too less. So that's why we have this LOIN principle within buildingSMART: level of information need. On the level of information, also level of geometry, documentation that you need, and the level of detail that you need. Well, this is the cube distributed in the subcubes with all the different systems. Just, I mean, you know what this is, but also from it's separated once in the detail, in the project phase, the type of systems, and also the methods that we use. And this is one thing where we have this open BIM standard, but also closed BIM, where you have special planning software that has to be transferred then later into open BIM because the customer may require it. And then it has to be IFC. And you have to make sure that if you transfer it, that the socket is not missing in IFC. Also, you have it in your closed model. That's it. And you can also connect to me on LinkedIn. I have also a paper posted on LinkedIn about BIM in electrical engineering that describes it in more details. And if you have any questions, please come back to me and we will discuss it. We would also appreciate if you work with us in our electrical domain room, bring in your experience, your demands, also what you need, and see how we support us in moving on and going especially in the right direction, because it's quite a complex topic. Thank you very much, and now I will hand over to Andrea.
Thank you very much. Thank you, Christian. Okay, now I try to show you some results of the BIM in electrical fields. How many of you are electrical engineer? Okay. Do you use software? Okay. BIM software? Okay. Thank you very much. Okay. Today I will talk about three main topics. One is the BIM for low voltage systems, BIM for medium and high voltage systems, and then I will tell you about an experience in the Italian buildingSMART group about fire detection system in OpenBIM. We have done I think, a very interesting work on this topic. So I will show you the results in the last part. Briefly, who is H Software? H Software is an Italian software company. Italian software company developing software since 30 years for engineers, for architects, and especially for the BIM. And we are very committed in the BIM and the Open BIM field. We are very proud to be the winner in 2019 of the BIM Awards. And also last year we have a special mention in the same award. So we are very committed in this field. My name is Andrea Aiello, and I work for Alma. I'm a CEO of Alma. It is an H software company, and I'm very committed in the electrical fields. I'm part of the Italian Electrical Committee working on the BIM. And also I contribute actively to various buildingSMART international projects like IDS, BSDD, and now I'm a member of the electrical domain. So let's start to talk about low voltage system. I will show you our solution. It's a software for designing low voltage systems in BIM, directly in BIM, and then export the results in OpenBIM. Some parts are still in Italian because it's not completely translated, so I'm sorry for that, but I think you can understand the idea behind the video that I will show you. So, as you know, BIM modeling is not just 3D, but when you create a BIM model, you need to add some information, or the information may be the most important part of a BIM design. So in the software, you not just create the 3D of a low voltage system, but you also add all the information you need to create and to do some use cases that I'll show you later. This is Edificius. Edificius is the software by Akka that is able to create low voltage system. Really, it's also able to create the other mechanical and plumbing system, but let's focus on this. As you can see, it's quite straightforward to use. There are all the objects present in a low voltage systems, and you can create this object in different way. Now let's start from creating a box and add this box to the architectural model. You just can get the box. You can choose some parameters. So it's not just a 3D object, but there are some parameters that we are going to use later for some calculation. It's very, I will stress about this, but you can see it's very straightforward to use. You just get the object, and then you have some tools to put this object on the wall very, very fast. So let's add another box. I'm trying to show you live how to design this low voltage system directly on 3D and not from 2D. Now I'm changing the name or the size of the stuff. Sorry, I need to change my glass because it's quite far. Okay. Now I'm just going to add the simple device to each block inside the box. So I have a list of objects from we can choose. Let's choose this switch and just select the place where the switch is. So very easily I can add more devices to the same box. Let's see another example. In this case, we will add a plug. All these objects have some properties that you can see later. If you export in IFC, you can read the same properties directly in the IFC without any loss of data. Also, it's very important to see that when you move, there's this dynamic view that some walls are hidden, some are shown in order to work very easily in the 3D view. Now let's add a box, distribution box, from by using different parameters, you can create different box with different sides, but also in this case, quite easy to add to the 3D model. Now we are going to add the light. And to do this, we are going to the 2D. We are going to create a grid, a magnetic grid. We call it magnetic grid with some rows and some columns with different position. This way, we will add very easily all the light in the right position in just one way, one shot. So we have created this grid. We put this grid in 2D, and then we can add very easily the light. So we will choose again an object representing the lights, square lights with different sides, and just doing this way, we can add all the objects in one shot in the very precise position. And now we can add more and more objects. For example, we have all the objects. For example, this is an UPS. We have generic models, and also we have a library with a specific model produced by many companies. So you can choose also from a catalog of a library of BIM object produced by all the most important companies in Europe and in the world. In this case, I'm using a generic one. I can just add other type of electrical device. In this case, I'm going to add something for the home automation sensor. And so it's in the same way I can do also this type of systems. So you can design not just low voltage system, but also alarm systems and the other type of electrical systems. Okay. And now I'm showing you how we can create ducts, how we can connect all these objects together. Again, just we select the ducts, the dimension, and we can do directly in 3D. We can use these very useful tools when you can just draw your ducts easily, just turn left, turn right, go forward, and connect one device to another in few steps. As you can see. So very easily in this way, you can create your systems and create also the connection and all you need to do that. Now I'm just showing you how to use another type of duct, a square duct. And as you can see, you can use this tool to go forward or to change the angle and move from right to left, you see, and have another view of the same model, and just quickly to create these models. We try to make the most effort to make it very easy to use, because we believe that if you want to use a BIM modeling tool to do electrical system, you need to do it easily. Otherwise, you don't do it. You just still use other tools, not BIM tools. But in this way, we believe that you can do it very easily. And then the very important thing is that here you have now a model, and with this model you can do more stuff. I'll show you later. So this is the final result. So this is a low voltage system, a 3D, but also each object has many properties to do a lot of stuff. First of all, we are using this model to calculate many stuff, many things. Sizing the protections inside the switchboard, sizing the cables, balancing three-phase systems, for example, checking the occupancy coefficient of the conduits, and also you can verify the overheating panels. But these are just some use cases that you can do with our tools. And because now we have a model of the system with all the information that we can use for many use. So let's do, this is an Italian part of the video because the calculation is ready only in Italian now, until now. As you can see, you choose the switchboard. We have many models of switchboard. This case is a small one, but we can create as many rows, as many columns we want. So just fix the switchboard to the wall. And now let's model the switchboard in a very easy way. I don't know if you recognize this type of input, but this is the input, at least in Italy, we use since maybe 20 years to create or to design a switchboard. So create the tree view of the protection devices, then just design the front end, and then go back to the BIM and see that the switchboard is ready with all the information that we need for each protection device. But most important thing that you can make some calculation. You can check for if the protection devices are good or not. And if are not good, you can automatically choose the right devices. Here I'm choosing the product firm. I am using Biticino. It's an Italian producer of devices. And just one click, I can design the switchboard because I can choose the right protection device for the right position. As you can see here, there are all the information calculated, ICC, short circuit current, drop voltage, all the calculations are made to be compliant with the Italian laws. That they are very similar to the other European country, but now we are focusing on the Italian one. Here I have all the information about voltage drop. So, and also I have some report from my calculation that I can produce to my client. And so this document is produced by starting from the BIM models. This is very important. So this is the final report with all the results of calculation that we have done. Okay, it's quite complete. And this is possible because all the models, all the devices has the right information. And also from the models, we can have the outputs now. Floor plans, layout section, but let's see very easily in this video. So for example, let's say that we want to add a floor plan of this model. Just add this object here, and automatically you have the floor plan with all the devices. You can show the electrical symbols close to each devices. You can add these tables, this information here, so you can create a very, very good output documents easily and quick. And it's also dynamic connected to the model. So if I remove, add an object, it will be changed directly, immediately. No need to remember to modify all the output as soon as you have a change in your model. But also, yeah, here we're adding some electrical symbols as required by the standard. So just select the object and automatically you have the same symbol. And you have a very, very, very good output from your model. And you can improve it as well to adding some legend, and also these legends are automatically generated. So now you have the BIM model, you have a lot of things. You see here all the electrical models used. Another one here, so you can compone your output very, very, very easily. This is a section of the same from the same modules. For example, here we are watching a wall where we can see all the elements in front of the wall with the sign, the symbols, the age of each module, and all the information that you need if you're an electrical engineer. I think this is very valuable because sometimes what happens is that you change your project, you forget to update all the outputs. So the outputs are not more valuable if they are not updated. In this way, they are updated, and then you can create rendering very easily because just put a camera position inside the module and generate the rendering very, very easily. You can show your result to your client very, very well. Yeah, you can use also this screenshot and this render to improve your output. We are putting together many output to create these working drawings with all the information still updated and valid for your models. So as you can see, it's quite useful to use BIM tools to design your electrical system. And if it's open, it's better. So because later you have a model that you can exchange with the other people inside your working group. We can create tables extracting information from the modules, tables of every element. For example, let's take this type of information from the models, a table of some object filtered by using some query. For example, we can okay, we can use the module as well to create tables, but also create the quantity takeoff. So, for example, in Italy, a lot of clients use the software to calculate the quantity of each object. As you can imagine, it's calculated automatically. You don't need to do anything. You just need to say to the software, I want to count the number of plugs, the number of box, and that's it. And then you add a price to this object, and automatically you get the price of all your systems. You can group your price in different way, but yeah, you have a live calculation of the price of your system with just starting from a model, from a BIM model. Yeah, you can count, you can sum, you can do a lot of things that usually you do, but starting from a list of objects that they cannot be the last version of your project. Here you are sure that you are using the last version of your project. Here I just want to show you some nice stuff that you can get from your, again, from your model. You can create a very nice rendering. Just put the camera, that's it. You have the render of your system. Then you can now hide some walls and see the low voltage system in a nice way. So very straightforward. You can have some very nice output. You can change the time of the day, and yeah. So you need to have another tool to do all this stuff. Just one tool to make also this type of output. Now I'm starting rendering to get a better quality image. That's it. But you can also create video of your model, just showing your system, electrical system, just doing a video like this, just to show to your clients live what is going to happen to their buildings. Okay, now the other part of our presentation is about high voltage. We have a nice experience with the Italian company Terna. Terna is the Italian company owning the network. So what we have done with them, we have just created the object, a library of 1,500 objects in OpenBeam for represents the high voltage and medium voltage systems. So we help them to create substation, to create the transmission of the high voltage power. And also, as I show you later, there's this also a connection with GIS. So we help them to put all these transmission elements on a map, on a GIS map, and use them for maintenance. So now they can, they have, before this work, they took weeks to create substation. After they can create a substation in just a couple of hours, because they have all the objects they need to create it. A powerful wizard to start from just with some question, and just very easily they can create the substation. let's have a look to, so we can do a lot of stuff. Look, we can we have done this object with geometric, but also with all the information they need for use them in the maintenance phase. They are in 4.3 standard format, 100% open beam, the easily access to LOD and data. So the work is changed now. They can use these open beam models in a very powerful way, and the work is changed. So really, open beam is already here. This is a message I want to give you just from the beginning. But open beam is also possible now. There's a lot of work to do. We are trying to do it here, but there's a lot of work already done, or you can use. So this is the tools that we use to create this substation, just starting from, as I said before, from some very easy questions, and then just to grabbing this object from the library and put this object on top of the models. And this is the final results. Each object is not, as you can imagine, I just repeat, but it's obvious that each object has many information, not just geometric one. And it's very easy to use, and the results, yeah, as you can see, there is all the information that Terna wanted to add to this system. Now we are following their needs, but we can add more and more properties. And the second part of the presentation is about the transmission. We have also done this work with them to implement and to model the transmission elements of the power, electrical power. And we have put this information on GIS, so now they can see and look at the transmission network in a different way. It's always the same way to work. We started from analyzing all the objects inside their systems, model them in OpenBeam, add the properties they need in OpenBeam as they, with the name and the property and the value they selected, and now they have a library that they can use to start and to create quickly the transmission systems and update it also very quickly. So starting from modeling the site, starting from Google Maps or from other system, we can model the tower and then connect the tower each other just in one click. Also, you can add all the devices that you need, in this case, the insulator strings, and all the elements used in this type of electrical systems. Also, the foundation, for example, was very important for them to have information about the structural information of the tower. The positioning of the ground protection, position of the signal balls, spacers, vibration dampers. So very quickly they can create this network just by using a library of OpenBeam objects. And this is the final results. They can navigate in real time and have a closer look to all the elements. So they are using OpenBeam. It's not just the future, it's already present. Now we need to try to put this property in a standard way, because now we are following their condition, their documentation, technical documentation, but maybe I think the work now is try to create a standard for this type of object. Like we are doing for the low voltage, we should do also for the medium and high voltage, but it's just a problem of agreement between all the OpenBIM community, but yeah, we can do it. And also you can see it immediately, so it's very, very important for that. And the last part is this work that we have done in Italy. In 2021, we joined, buildingSMART Italy joined the Italian Electrical Committee, it's called CEI, to create a working group on OpenBIM for electrical system. Me, myself, Stefano Ricatti, Fedele Rende, and Franco Bua from CEI were the leading people in this group, and I want to thank you again to all of them. So we start to work about OpenBIM and electrical system. So after some discussion, we decided to work on a specific system just to create a proof of concept. We starting to model the fire detection system in OpenBIM, because this system is comprehensive, but not overly complex in terms of its constituent elements. So it's complex, but not so much, so we can tackle it. And so we try to follow the buildingSMART process. So starting from the requirements, then create the model, using the BSDD to enrich the model, and also to create the IDS to check the models. So we try to follow these steps. So first step was to identify all the components of the fire detection systems. And also the second step was to identify all the relevant properties and all the relevant standards in IC, EN, and UNI and CEI standards. So we were very focused on trying to understand very well where are the source of the information we are going to use. So which property, in which standard, in which, if from IES or from the Italian standard or whatever. So for each component, we have defined the main characteristics based on these relevant standards, try to ensure robust semantics. Then we have specified an FC class. So for each element, we go through the FC standard, we select the FC class, and also the predefined type for each of them. And then we have created a data dictionary, a BSDD. I don't know if you know about that, but it's a line service from buildingSMART, a dictionary where all this information are saved. The main components of a fire detection system, if you don't know it, they are just a detector, signal device, control and signal panel, power supply, module, and system. So we identify the components. For example, then we go forward for each type of components, maybe there are sub-components. I mean, the detector, okay, but there is a detector, a point type smoke detector, linear detector using an optical beam. So we identified all the detectors inside a system. For example, we have identified a smoke detector. We decided the smoke detector is an FC sensor with the predefined type smoke sensor. And we have found some properties, minimum supply voltage, that will be an FC real in FC, rated operating voltage, and so on. So we have identified all the properties, starting from the standards. It's very important to say this. Then we have also decided to use the system distribution system to put all these elements together. So we have defined some distribution system inside our system. And then we have created this BSDD. So we have collected all this information and create a buildingSMART data dictionary. In this case, we have used BSDD editor from ASBIM. So we have created all the data dictionary for fire detection system. Here is the hierarchy. On the left, there is the hierarchy of the objects. So detector, alarm, panel, power supply, and then there are some subcomponents. On the right, you can see the properties assigned to each object. This is the list of the properties that we have defined, that we have assigned to each device. And then we have done an IDS to check the quality of an FC file. So, I mean, if you want to be sure that the FC model is compliant with your rules, you can use IDS. I don't know if you know this new standard for coming up from buildingSMART, but this is, IDS is information delivery specification. It's used to check the properties inside the file. So for each element, we have created an FC file to check that all the properties that we have required are there. And this is, we have done this with Asvim IDS editor, and for each element, as you can see on the right, there is a specification. I mean, a way to say that all the IFC detector must have these properties. If they don't have, there is an error. For example, for the smoke detector, we have this rule that all the IFC sensor classified by using our classification system, they must have these properties. And finally, this is the final video to show you all this stuff together. So this was, we have created this IFC OpenBeam model with following all the instruction that I just talked about. In the documents, we also say that we need to use a specific IFC structure. So all the, for example, all the elements must belong to a story, build a story. This is the list of sensors, the control systems. I'm sorry, this is also in Italian because, yeah, this was done for the Italian project. As you can see here, there is the control system. There must be an IFC unitary control element with this predefined type, control panel. And here there are all the properties that we have written in the documents that we required. This is another control panel for the second system. There were two detection systems. This is an alarm. IFC alarm with the predefined type light because it's a light alarm. And here you can see the properties required by the documentation and that we have written. This is an FC sensor, as you can see. So class FC sensor, predefined type smoke sensor, and properties as required from the documentation and from the IDS. I just want to show you this example because I think this can be used in other situation because it's quite following the buildingSMART process. So maybe it could be a very useful experience to share and to. So this is the buildingSMART data dictionary. So just I created this list of all the elements inside the system detector for each. Then I create some specific detector for different types, and for all these types, I just added some properties. I specified the IFC class to be mapped with these devices, and then here we have all the properties that I used to enrich the devices. Then I just uploaded this BSDD to the online service from buildingSMART. So you can create your classification system and you can upload to the server, and then you can use it later for enrich your model with this classification. And this is what we have done. So now I'm going to show how to upload it to the buildingSMART dictionary. You need the user ID and password, but then it's very easily. After that, it's on the web, and so you can use it. This is the IDS that we have done. As I told you before, there is a specification for each type of element, and for each specification, they are in this way. There's the first part, there is a filter where you say which class, in this case, IFC sensors class must meet specific requirements, so must have some properties here. Okay, this is another example, the same stuff. We filter the FC element by using the FC class and the classification, and then we require from some properties. The schema is always the same. This is the final result, an XML file as the standard will tell you. And after that, when you have an FC file, you can load this IDS inside another tool called ASBIM IDS and see if your FC file is good or not. So what we are doing is we are checking for all the required information, and in this case, everything is fine because we have done in the right way. So we have no errors. Otherwise, here we will get some red columns and say that there is a problem. Go and try to fix them. So following this process, starting from IDS and BSDD and IDS again, as you have seen before, you can create your model, and you can also extend this process to other type of systems. Maybe they are more complex systems, so it's more difficult, but the process is the same. So you can. I think it's very nice to. The final result of our job, our work, was a PDF document. It's in Italian, but we are going to translate it in English quite soon. An FC file that you can use to do your stuff. You can use to do your test. We have done also an IDS file that you can use to do and to have a look to understand better what we have done, and also a buildingSMART data dictionary that is on the web. So you can have a look on the web to our buildingSMART dictionary. So if you want to scan this QR code, you can download all these documents, but they are still in Italian, but it's a good starting point. So I'm finished. Yeah. Thank you. No, if you have any questions.
Maybe until the battery is recharged, I would also give you some more information on, especially on the smoke detection system. There is a association called EuroAlarm, and in this we are also active in this association, and we will also publish a white paper by summer about BIM in the fire detection, fire system solutions, because it is much more than just doing the drawing. You have to fulfill a lot of regulations, and this must be also checked that you have you fulfill these regulations. Otherwise, your building will not open.
Okay. Thank you very much for this very interesting presentation. I have some questions. The model you had for this low voltage, could that be exported as an IFC model?
Yeah, sure.
And I mean, there are symbols also. Not all the geometry are carried out as IFC geometry, all these boxes and so on.
So say again.
All
the geometry, yeah, they are carried out. All the geometry.
Yes, but the symbols you had on the 2D drawings.
You mean the output? Where, yeah,
Yes.
the output it's not carried out in IFC. So the output will stay still in a diffuse. What we are doing now is trying to extract this output directly from the IFC. This is something that we are doing in ASBIM. So we are trying to use the IFC file as a starting point from the delivery, not just for the electrical system, but for everything. So basically, in the next future, from the IFC model, you can create your floors, plan, your section, everything directly from IFC.
And if you update the 3D model, will some of these other representations also be updated?
Yeah.
Excellent. And a question about other systems. We look at, for example, ventilation systems where you have big aggregates and fans, and they are sort of never identified in the modeling, in the BIM models we have in Sweden, for example. Are you looking at that also, to have that complicated, multiple systems in them and so on?
Yeah.
Thank
you. Anyway, you can try the features for free for 1 month, so you're free to use them. Unfortunately, you cannot use for high and medium voltage because our work is still work for Terna, so it's not public yet. But yeah, otherwise you can use the features and see all this stuff. You can test them.
I'm aware there's a number of definitions of a digital twin, but in our organization, a digital twin is a model that can handle real-time data. So IoTs, whatever sensors, to do preventive or predictive maintenance. I'm interested to hear, where are you heading in this direction to actually act upon real-time data in a real-time mode?
For me, yeah, we are working on that direction because there is another module or ASBIM of our platform. It's called ASBIM IoT. And this is able to connect the OpenBIM model directly to the OpenBIM IoT devices. So you are able to connect these devices by using open standards or also legacy standard if it's possible. And this way you can directly selecting, for example, sensors, you can see the data, the real time, or also you can have a look at the historical data. And we are working with algorithms, machine learning algorithms to make maintenance prediction and all this stuff. Yeah, we have this idea. Our platform is open, so we are connecting the model to external system, not just for IoT, but also, for example, for maintenance or for property management. So the model is also, I can say the model is the core of all your business, because you can connect everything to the model: property, IoT, maintenance, GIS data now. So you can have a real digital twin.
Yeah, this is exactly the question we discussed in the previous session about how to handle real-time data, runtime data, and because the IFC is a skeleton of your body, you bring in the products, which are your organs, and when the heart begins to beat, then data is generated and must be handled. And this is exactly how it is. And you have to define exactly already in the design phase, what type of data do I need in what time frame. And for this, we are looking at the moment into the asset administration shell, which is also a standard. And with the Industrial Digital Twin Association, we are also a small group on working on, hey, what works in the factory should also work in a building. So we try to bring together this BIM and asset administration shell exactly for the purpose of the operation phase of a building. Because in the operation phase, this is 80% of the life cycle. and nobody looks at it. Everybody thinks, well, with a key handover, my job is done. But this is not the case, because then the real business starts. And this is what I just said. Asset administration shall check out, send me a LinkedIn connection, and then I will.
Yeah. So where can we find some more information from your side? So I can send you a link in question.
And we want to have this standardized,
Yeah.
not in a single software. It should be also open, transparent, and so on.
Sure.
And you have a smart meter. What do you expect from this smart meter? You define in the design phase what should he deliver, kilowatt, amperes, or I don't know. You define it, and then the specification must be fulfilled. And later on, you get this information via the runtime data, and you compare whether the design was fulfilled.
Sure.
Maybe also one more additional information, because Andrea also showed the high voltage. There is also now high voltage going on. Fabiana was giving a presentation on the first day, yesterday in the morning, about the high voltage stuff. They also go into BIM now, yes, Peter? And we are now discussing how do we bring this together, the high voltage down to the low voltage, to avoid double work in standardization. It is a bit different, but we need to see how we get this all. It's all electrical, but we need to see how we get this coordinated, let's say this way, in the electrical domain.
Really nice presentation. Thank you very much. And
Thank you.
I see that I see that development is going forward, because the GIS topic is new in this case, and it's present for us that we are working on that, and connected to what you are doing also with IoT and digital twins and so on. Of course, we have so much to do, and we are not there. We're basically not there. That's the truth. But we are working on that, and I guess that the exchange that we are doing here is good for the future and good for work. So.
Yeah, I just want to show in this presentation that electrical BIM is possible. So now the technology is there. We just need to make an agreement between all of us to try to find the right way to do that. But the technology is here, so we can support, like as a software vendor, to your decision. So we are ready to support your decision about the properties, the geometry, and all of stuff. So the technology is ready to GIS, BIM, and IoT. So very interesting to create a standard so we can make less work, because if you have a standard, you do less work in developing, and to support you.
Yeah, then thank you very much for listening, and let's continue.